Right, well, here we are. I'm Matt Lynett, and today I'm going to react to a video with Jonathan Blow. He claims that software engineers have no deep knowledge, and I tend to agree with that point, and that's the reason I'm going to react. I'm going to see what he has to say, add my own thoughts, and y'all get to let your opinions be known in the comment section below. Let's get right to it.
I think there's a pretty serious problem that started happening in programming culture. I mean, it's been in programming for as long as I've been in, and this is beyond games even. This is everywhere. Yeah. People don't have a clear picture of what knowledge is deep versus what knowledge is shallow, right? So if you go to school and you're a good student and you learn that
people don't know the difference in between deep and shallow knowledge. That makes a great deal of sense. Deep knowledge, I'm going to guess, the way he's going to probably go with this, is that deep knowledge is somehow axiomatic, or it's fundamental to understanding how a system works, and shallow knowledge is just barely scratching the surface. Shallow knowledge is what you see at first glance. Deep knowledge is what you can apprehend about a whole thing that's undergirding the way everything works. For example, shallow knowledge could be, I can program a web app in Django. Deep knowledge would be, I know how a computer works, I understand what a processor does, I can optimize my code accordingly, and consequently, it doesn't matter what kind of code I'm writing. I'm going to be writing, I'll write a good web server, I'll write a good OS, I'll write a good whatever. And in the industry now, folks have gravitated toward knowing one little teeny shallow discipline really well, and then hoping that that discipline will carry them through their career. So they get to learn, say, Django, or they get to learn React, or they learn whatever that little thing is, and they hope that that will get them through whatever projects come their way, whatever pays the bills. And consequently, they don't actually write good code at all. They just go to Stack Overflow, go to ChatGPT, go wherever, get some thing that looks remotely like what they want to do, copy that, throw it into their code base, and whoop-de-doo. There they have a solution that they completely don't understand. They've probably introduced bugs into the code base, all as a consequence of having shallow knowledge and being too lazy or ignorant to go and pick up the actual deep knowledge that undergirds what's going on.
the difference between n log n and n squared, right? That's deep knowledge that will apply in many cases, and it's something fundamental about computers, right? On the other hand, if you go on Hacker News and read an article about somebody learning a specific JavaScript API and tutorializing it, right? That's very shallow knowledge because it's just, you're learning about arbitrary decisions that somebody made about how to interface with a thing that you're not even trying to understand, right?
Learning arbitrary bits of knowledge about something somebody else made and not even trying to understand that actually, yes. So he uses O of n log n versus O of n squared as an example of deep knowledge. So that's regarding the performance of a program, how much memory or time something takes to run. And if you make bad decisions regarding that, you're definitely not going to be able to have any kind of performant applications running that are beyond trivial, because you will, by definition, make wrong decisions.
Be made about how to interface with a thing that you're not even trying to understand, right? But that knowledge became very popular since, let's say, since 2005. Once once this second boom of programming happened and everybody realized, oh, you can make a lot of money in programming or whatever, all these people showed up and they just want the job where they could do JavaScript, and so they just learn the API, right? And so there's been a...
They just want the job where they can go and do JavaScript. Yes. Yes. Or some people just want the job where they can go do Java. All right. It's whatever little corner of the universe they're in. That's all they want. And they're there to make a buck. They're not there to understand. And consequently, they're not going to be the ones making the big bucks. You know? Would I hire a surgeon that just learned what a scalpel is the other day to go and cut me open and get rid of a tumor? No. I'd want somebody that understands the human body, someone that understands anatomy, physiology, someone that has good hand-eye coordination, somebody that has good stamina, somebody that has who's almost psychopathic enough to be able to cut somebody open and not feel too much so they can go and do the job. I mean, there's all sorts of elements that go to being able to cut people open and do good surgery. In the same way, there's good things, or there's all sorts of things that it takes to make good software. We've had examples of bad software developed and killing people in the 737-800 airplanes. People didn't understand the business case. People didn't know how to write software to meet the business needs, and people wound up crashing these airplanes because somebody somewhere along the lines didn't have an apprehension of the situation enough to say no. And the only people writing code are probably underpaid. And they probably got into the field just to make a buck because mom and dad said, oh, software engineering's a good field, you should get into it, even though they have absolutely no chops for it and no desire to actually do a good job.
A deluge of shallow knowledge. It's a little bit more complicated than that because part of the way that you learn deep knowledge is by looking at shallow things and reading the pattern underneath.
Okay, that's a point. That's a legitimate point. Part of the way you gain deep knowledge is by looking at shallow things and seeing the pattern underneath it all. Yes. So you can get an idea of, if I have to do the same kind of a thing 100 times, but it's a slight bit different every time, what abstraction can I pull out? And that's probably something fundamental to computing or to solving the kind of problem that I want to solve or that I'm getting paid to solve. So yeah, you can definitely do that, but the problem is most people don't. Most people just go and see the one thing, copy paste it, and they're done. They haven't thought about it. They haven't made the appropriate abstractions in their own mind, and they consequently won't even know what abstraction to pick if somebody else has written it. These are the people that are hapless and that will be exploring Stack Overflow until the day they retire, just to get the basic conceptual answer. Stack Overflow has a place. If you know what you're doing and somebody else has done it already, you can go and save yourself a lot of time by going and asking, how do I do this very specific thing that I want to do? But if you're outsourcing the engineering work to somebody else on Stack Overflow, that's just bad. You don't do that. That just means you don't have deep knowledge. I like his verbiage. You don't have deep knowledge, and you suck. That's basically how that works.
If there's an API to do something, if it's a good API, then by looking at the API choices, you can understand the problem and the mechanic. Even if you can't see the code, it's better if you can see the code inside. But if you can't, you can still see some things about the mechanics. And one example of that is a graphics API. It's like, okay, they want me to put the vertex data into a buffer and lock the buffer and then not touch it. Why is that? Oh, it's going to the GPU and all this stuff, right? You can figure this out. On the other hand, if it's a bad API...
You can figure this out. That's something I'm not entirely convinced of. Maybe they can, but most people will not read. Most people will not explore. Most people will not ding-dong around enough to actually understand what's going on. Maybe 2 out of 10, maybe 1 out of 5 developers will. The rest of them will just go and not. And as far as I'm concerned, that's atrocious. You shouldn't be doing that. If you're that way, just snip the cord in between the keyboard and the computer. Snip the cord in between the mouse and the computer. Just sit, warm a chair, and clock out and go home when it's your time to leave, because you will be doing people more of a favor by not generating bad code and being a seat warmer than by generating bad code and making other people pick up after you.
GPU and all this stuff, right? You can figure this out. On the other hand, if it's a bad API, which most APIs are, it'll be full of stuff that's stupid.
If it's a bad API, it will be, which most of them are, it'll be filled with stuff that's stupid. Yes, because most people are stupid, and thus make stupid APIs. Or most people are inexperienced or undisciplined or something like that. Definitely unprofessional. Right? Because being unprofessional, not having something to profess about what it is that you're doing, not holding yourself to standards, not doing things right, means that even if you are smart, you're going to be releasing crap. So people definitely aren't going to be able to learn from you. People will be scratching their heads wondering what in the world you're trying to implement. And everything that you touch, rather than turning to gold, will turn to crap.
And or even cargo culting, where they're copying a good API. So my favorite example.
Yes, copying the good API without having any clue what you're doing. You copy the API. It doesn't matter what it does. This is a popular one. Let's just follow all the design patterns contained therein, rather than going and actually looking at what problem I have to solve with my code and solving it and translating that solution into good, readable, performant code.
Example of this was when Microsoft did Direct 2D, which was taking Direct 3D, which was successful, and then trying to add font rendering and all that to that. They made an ARGB color, right? So red, green, blue, and alpha, a lockable resource. So to create one of these, you had to lock it and fill the color data and unlock it. And I'm like, you have no idea what you're doing. And I actually...
ARGB data. So that means you have a red value, a green value, and a blue value, and I think it's alpha. And so you make the resource, lock the resource, populate the resource, unlock the resource, and then you have it. Because reasons. And there's your color. Okay. That's the case of somebody just copying a design pattern from something that actually does make sense. Like locking things that are actually going to be used in a computation that needs to take place at this exact point in the program, and you don't want to change halfway through because it'll screw up whatever computation or introduce a race condition, or why would you ever do that? But okay, so yeah, just copy a pattern. Don't think about it, just copy it.
Actually told Microsoft this, and they did not like my opinion on that. But they were just copying, Direct 3D has you lock things and fill them, and so let's do that here. And it was completely absurd. So, how to fix it? There just isn't much of an idea right now of what an actual respectable engineer is. You know, like if you...
Okay. I'll give him that to a point. It's very difficult to articulate what a good engineer is. But there are resources like the Software Engineering Body of Knowledge, and there are abbreviated guides to it. There are cookie-cutter plans that people follow to design apps at enterprise scale. Like you can have ER diagrams, you can have class diagrams, you can have data flow diagrams. But even then, lots of people will just go and copy-paste designs that they've seen other people do because it's familiar to them. And people then go and they wander into the field. They pick up whatever skill set happens to be popular, and then the familiarity keeps them there. They don't want to expand. Yeah, that's not cool. That's pretty miserable.
Think back to like civil engineering, like people who build bridges or whatever. You think of people who are responsible and know things well and make sure they're right because it's important to be right. We don't really...
Yes. Yes, they need to know what is right. And real engineers will have at least a gut feeling to know what is right and the ability to go and check themselves and see that it was wrong. Like you can pick design patterns and you can pick frameworks that go and make choices for you, or you can roll things completely yourself. You can do any of those choices. And ultimately the question is, can you solve the problem on the table in front of you in a sustainable fashion? If you're building bridges or sewers, people will die if you fail at building a bridge. And so the point is, you will build a bridge to a particular set of specs that says you're going to paint this bridge every 5 years, and you will destroy this bridge after 50 years because it will have gone through too much material fatigue. You'll do that. And that'll be how people do their bridge building. Same with sewers. The sewer pipes will start to corrode all the way through after 150 years, so be prepared, everybody, 150 years from now that you will be replacing the sewer pipes. Or you will be doing something different that we engineers haven't yet come up with the thing. But for software, very few people actually think about the other people that have to touch the code in the future. And they technically, you would say, they turn it into hardware. Remember, hardware is fixed. You can't do anything to it. Software, you would expect to be able to have it be malleable, moldable. You should be able to do something to it. But if you write something that's not readable, something that's not understandable by somebody that has a minimum of a clue of what you're doing, all of a sudden you've created a piece of hardware because people are going to be afraid to touch it. People are not going to be able to touch it. People are not going to be able to reason about it. And on occasion, it'll be easier for people just to start fresh, make a new thing, and pitch your thing away, when the change might have been something as simple as to adding 2 lines or adding a line and deleting another one as some requirement changes 5 years down the road. But also, zeros and ones are more abstract than bridges. Like you can go on a bridge and look, and you can see where there's a weak point. But you need to actually know a lot about coding to be able to go and look at a piece of code and say, here's a point where somebody has introduced unnecessary complexity. That introduction of unnecessary complexity just indicates either a complete lack of time, or lack of thinking, or lack of understanding about what's going on, or I don't even know. I don't even know. We'll see what Jonathan has to say.
We have that in software at all. It's completely dead as far as I can tell. And part of the reason it's dead is because nobody can tell what's right, because it's just a bunch of people arguing in a loud room and like no real information gets through. And if anybody has an idea how to solve that, I would love to hear that idea. I don't know. The only way that
The and only a little information gets through. Okay, that guy's an INTJ. But only a little bit of information gets through. You're not even having people that understand the problem talking. It's just noise. It's literally nothing more than that. It's just noise. But he still doesn't propose a solution, so I don't know that you can. Besides, I mean, I guess the market does kind of sort out for people that can do a good job. But there's something more to be said about, let's say, people who can, or who know what they're going to do it, and can assess the situation and act accordingly after they've done what they've done to realize whether or not they've solved the problem. And then who take the appropriate size bytes, make those things, and then compose them all together to make their program. But that you're not going to teach in school. Nobody teaches that in school. I mean, in school you can learn certain things. But really, you would learn all of this a whole lot better by growing up in the 80s, let's say, and building your own computer and having to program it from scratch. Because he said, what did he say, 2005 was when this started happening. Well, that's when regular PCs started becoming affordable and usable, and people didn't have to figure out and hack things together themselves. So technically they viewed the field as being more accessible, and so they got in without doing the work that everybody prior had to do in order to just learn to function. Right? And now you wind up getting kids that are trying to do this that don't know how to look things up, that don't care to learn how things work. They just want the end result. And these people are the ones designing and running the world. I kid you not. These are the people that are designing the systems that stream people's TV. These are the people that design the systems that stream people's phone calls. These are the people that design systems that launch missiles. Though I would say that probably those other things wind up necessitating a certain amount more discipline, because I mean, I've seen what government contracts are like for just simple web design things. So yeah, forget that. People, it's always the children that produce the majority of the code. And by children, I mean like anybody who's immature. Because as soon as you end up getting to be mature and you start developing code really well, then they want you to be in a lead role or a managerial role, and pretty soon you wind up going and telling other people how to code, because your skills are better used there. But then that means that every little teeny bit's a learning curve for whoever's there. And if the people that are in charge don't have a mind to teach, and don't have a mind to explain, and don't have a mind to share, and don't have a mind to grow other people up in the doing of a good job, they don't have the mind to mentor, then you're going to wind up having people that spend the entirety of their careers, or at least until they wind up getting somebody competent helping them, building crappy software.
That I know to solve it is to just do better in an obvious way. But even that maybe doesn't win, right? Because all these JavaScript frameworks are still popular, even though they're all
Yeah.
the same as each other, right?
You have NPMs to pad things.
Yeah, technically doing something better than everybody else and just putting it out there for people to see should work. But the problem is there are so many bad ideas that it is actually impossible for most people to cope with the volume of information that's coming at them. To A, even be able to find the good idea in the first place, and B, even if they do come across the good idea, they won't have the mental wherewithal to be able to identify it. You know the saying from the movie, I'd wish you luck, but you wouldn't know what to do with it if you had it. It's like, I'd wish for you to stumble upon a good idea, but you wouldn't recognize it if you had it. So yeah, doing a good job is only effective if the people that you're doing the good job for actually appreciate a good job. And so yeah, ultimately, the free market will let the bad stuff eventually go away, but those gears grind incredibly slowly. But yeah, the free market, the free market will have people that can't bring things to market and keep them there fail. You can go and read many case studies about people that go and bring a product to market. They get their first feature set out the door. Everybody's happy, customers ask for more things, and then all of a sudden they cannot add those more things because they've gone and generated a bunch of technical debt, either knowingly or unknowingly. Whereas the people that have the slow and steady mentality of, no, we will not take on technical debt. No, we will not do a bad job. No, I will not ship garbage. That will eventually be the only stuff left. And then all the crufty stuff just will go to the side, and maybe make people a little bit of money, but it's eventually going to go away in favor of good ideas. But Jonathan, like many other people, we're impatient, right? We want to have what we want to have now. We want to have good software. We want to have people that are actually competent. We want to be able to say, this is what I want to do, and then have it actually happen. And that might be unrealistic because the percentage of people that can actually pull that off is astronomically small, and it's probably close to the absolute number of people that were in programming back before it was cool. Back before it was the thing that got the money. It was the people that did it that loved it and paid attention to it and became architects and craftsmen and knew what they were doing with their code. Those people are still the ones that you want to have around, because they're the same in this generation as they ever were. Those people exist, but it's just a small subset of them. And you just have to concede, well, the free market will take care of it, but yeah. Sad.
Because no one wants to write code anymore.
And in the same way the market can remain irrational longer than you could remain solvent, I think software industry culture could remain stupid longer than you're alive.
The market can remain irrational. Was it for longer than you're solvent? And software engineering can remain stupid for longer than you're alive. Well, so yeah, it seems like he and I basically concluded the same thing. You've heard the saying, the wheels of justice grind slowly. We as a species do not do a good job of dealing with changing systems. I think that fundamental human desire for stability makes most of us that aren't wired for this changing pace, this constant modification of something, just incapable of dealing with it, and consequently developments take place over generations, and it's almost always given to the public in the form of something cool. Like, say the iPad or the iPod, the iPhone. That's a physical realization of engineering problems being solved. The PC, that's a physical realization of problems being solved. But there's always some sort of a layer in between it. Like, you're not programming directly. You're not directly entering numbers into registers in the CPU. You have this interface into it. And the interface is very basic, it's very dumb, it's very human, touchable, usable interface kind of stuff. And if you don't have a cool interface that people can gravitate to, you're going to have a very difficult time selling things. And you know why Minesweeper exists? Minesweeper exists as a game to teach people how to use the mouse. Same for like Free Cell, Solitaire, that kind of thing. That's why those games existed on the computers, to teach people how to use a mouse, because they needed to be able to move their mouse here and there in order to interact with the computer, and that was a fun way of keeping people engaged while they learn how to use the mouse. Touchscreens were nice for people that want to just go touch and drag and do things, and then they have all these gestures that make sense given your hands and your and such. So that ultimately means that the people that are actually developing good stuff both have to be able to develop good stuff, and they have to know human nature well enough to figure out what people will and will not use. Like, the interface to any given piece of technology must be clear. Like, if you haven't seen people use a set of scissors, it'll probably, I'll just say something for my hands. I might put it in there. If you haven't seen people use a pen, that's actually a difficult one. You don't know what to do, so you can start monkeying with it. But a whole lot of these designs gravitate toward the most simplistic thing that people can go and use. So I would expect that that's the way that tech is going to go, is that all of the frameworks that people start making and all of the design choices that people make for solving a particular category of problem will start to roughly approximate the same sort of thing. I mean, I guess it already does. Like, you brought up all the JavaScript frameworks. All of them approximate the same thing. But there are certain ones that just do a better job than others in terms of being able to give constructs that you can reason about in the abstract. You can look at things like Elm, for example. Elm is easy to reason about, but people don't go and talk too much about it because React has taken a huge chunk of the market, and that's just what people know. But all these different things, they exist, and inertia will bring a great number of them to the point where we can converge on using something for a particular use case. And it probably won't change then very much in 100 years. Roadside flares, or flares that you use for signaling on a boat, those haven't changed much in decades. A door hinge, it's not changed much in centuries. Tables, it's not changed much in centuries. The proportions of a picture that you buy and stick on the wall, that's not changed much in centuries. And so software development is still very new. And I'd say that we largely don't know what we're doing in terms of making the interface to things accessible. And until we get our act together in that regard, I think we're going to keep on having arguing back and forth about how things work. Computer science is a new science, software engineering is a new engineering discipline, and we need to treat it accordingly. And what do you say about stupidity? And you'll die before the stupidity comes out of the software engineering. Let's see what he says. I'll buy that.
I think software industry culture could remain stupid longer than you're alive. Like, that's just possible. So I'm doing what I can do, but I'm very conscious that I have a limited ability to affect this giant thing.
There's been this sequence of abstraction that we've gone through as
I guess that all makes sense.
over the
I guess that all makes sense. Well, anyhow, those are my thoughts. I think he's spot on in terms of his criticism, and I think that he would benefit a bit from thinking about the design of things across all of history. And I don't mean taking piddly little UX design courses. I mean analyzing, like, I would almost say studying anthropology. Anthropology would probably be the field to go into if you really want to get better at UX design. You get to see the things that withstood the test of time. Yeah. So, is a study of anthropology the solution to people not having any deep knowledge? Probably not. But it might be the gateway to making the deep knowledge more accessible. You know, if people aren't making songs out of things, making pies out of things, and able to have their kids engaged in it, it's going to be a whole lot harder to get people deep knowledge. Like, you can go and talk with a good baker, and that good baker will be able to tell you about all the different varieties of yeast that he has in his kitchen. What you use it for and why, how long you stick it in the dough. And a biologist or a chemist could tell you about that and explain to you exactly the mechanisms behind it. And so, you'd have the baker being analogous to the engineer and the biologist or chemist analogous to the computer scientist. But until we have centuries of baking bread or centuries of making software, all of these arguments are still going to be had, and they're going to be constantly entered in by people that are new to the field too, so you're going to be constantly spinning your wheels trying to teach the same stuff. But, such is life, I guess. Such is life. The progress. The wheels of progress also will turn. Slowly. But they will turn. Anyhow, that's all I have time for today. Hope you have a lovely day. And talk to you next time.